Simplifying rational expressions is our topic for today. All of the examples that we do will be from your homework, except for this one. So, simplifying rational expressions is a lot like reducing fractions. Right? When you reduced a fraction, like, let's say you had something like this, 6/8. To reduce this, you look for factors that 6 and 8 have in common. Right? By now, you probably are doing this in your head, though. So I just want to go back to what you're actually doing. You're saying 6 is 2 times 3, and 8 is 2 times 4. Right? And then you're saying, okay, 2 times 2 times 3 times 4. We're splitting this up into two fractions. And then we are simply reducing that to 1. So we have 1 times 3/4, which is just 3/4. This is kind of the key step, right? We take something out of the top and out of the bottom, and then we cancel it out. But if I gave you a problem like this, right, 9/15, my guess is you probably just do this. Okay, take 3 out of there, I have 3. Take 3 out of there, I have 5. So the answer is 3/5. You don't actually probably write out the factors, but with these more complex rational expressions, the first step is going to be to write out your factors. Okay. So we're going back to like Gary's terrific trick and all the other factoring things that we practiced in the last unit. Alright, here is an example of a rational expression. Negative 36 x to the third over 42 x squared. So how is this different from the example that I just gave you? Well, the big difference really is the x's, right? The 36 over 42 and the negative, those are going to simplify just like you simplified.
But didn't we already do this?
Yeah, we did.
Yeah, you've done stuff like this. Yeah, stuff similar to this. Totally. This is sort of like when we were learning exponent rules. These are going to simplify a lot like we reduce fractions, because it's the same thing. Right? So 36 over 42, they both have a 6 in common. So we're going to end up with 6 there. We take a 6 out of that, we have a 7 in the denominator.
-6.
And then to reduce these, we use that exponent rule. We subtract the smaller one from the larger one. So subtracting x squared from x to the third leaves us just an x up top. Don't forget your negative, and then you're done. So negative 6x over 7 is the final answer to that. Now I want to point out that there's a lot of ways you could write that. You could write it as negative 6 over 7 and then times x. This is the same thing, right? And there are other variations you could do, like bring that negative back up front or just put the negative up top. When we're dealing with fractions, there's often, with factors, there's often a lot of ways to write your factors. All right. That one really should be reviewed too, because you've seen problems like that before. Let's do one that's a little bit more complicated. Let's say we had this. 2r minus 4 over r minus 2. The important thing to remember about this is you cannot cancel a 2 from here and here because there's another term here. Okay? So a lot of times the initial mistake people will make with these is they'll go, oh, I'm going to cancel the r from here and the r from there. I'm going to cancel the 2 from here and the 2 from there. That will not work because you can only cancel factors. Is 2 a factor of r minus 2? No. Right? We can only cancel factors. So, I guess we better factor this. How would you factor the top, 2r minus 4? How would you factor that?
Could you take out r minus 2?
Yeah, we could take out r minus 2, and what is left?
R minus, square.
No.
No.
2. Usually we would say that the other way around, right? Usually we would say, I'm going to take out a 2, leaving r minus 2 here.
Yeah, but, no, but, yeah, that's not.
Because 2 times r is 2r, and 2 times 2 is 4. Well, there's nothing wrong with saying I'm going to take out an r minus 2 and leave a 2. Okay, and then in the bottom we have r minus 2. So now, the factors of the top are 2 and r minus 2. The factors at the bottom are r minus 2 and 1. Right? There's always an invisible 1. So now I can cancel this because this is a factor of the top, and I can cancel this because it's the factor of the bottom. So I end up with 2 over 1, or just 2. I'm looking for factors that can cancel out. And what you're going to notice now, this is what's new about these, is sometimes the factors that cancel out are going to have 2 terms. So r minus 2. Usually when we've canceled factors out of fractions, they've just been 1 term. Right? I'm going to cancel a 3, or I'm going to cancel an x squared, or whatever.
Can we try another one?
Yeah, let's do another one. We're going to do several more, actually. Okay, so here's another one. We have 45 over 10a minus 10. So this one is kind of tricky because there's 2 ways to do it.
Could you take 5 out of it?
We could just take 5 out of everything right away. What I'd rather you do is factor the bottom first, because it's just going to get you in the good habit of doing that. Okay, so 45 over, to factor this, I just pull out my greatest common factor, 10, for times a minus 1. And now the factors of the top are 45 and 1. Factors of the bottom are 10 and a minus 1. But I see something that this number and this number have in common. I'm going to cancel a 5 out of that, leaving 2. I'm going to cancel a 5 out of that, leaving 9. So I'm canceling from this factor to this factor. This 10 is all by itself is a factor. I have 9 over 2 times a minus 1. And the other thing about these, if you had just gone ahead and canceled 5 out of everything, you wouldn't be done, because they want the answers to these in totally, completely factored form. So they want you to pull out that 2. So we have 2 times a minus 1 underneath the 9. And that's your final answer. There's nothing else that we can factor, and there's nothing else that we can cancel. So that's how we know when we're done with these. All right. Yeah. Let's do this one. X minus 4 over 3x squared minus 12x.
You let us do it.
So this one is the same as these, even though it doesn't look like it. All we're doing here to factor is pulling out greatest common factors.
Factor out of 3x on the bottom. Yeah.
Okay, let's look at the top. X minus 4. Is there any way to factor that? No. So we need to just leave it as x minus 4. Sometimes what helps, once you've figured out that that's the factor, is you just put it in parentheses. That's saying this is the only factor that I could find. in the top. I couldn't break it down any further. And then in the bottom, who sees a way of factoring this? Yeah,
3x times x minus 4.
nice. We can pull the 3x out and leave x minus 4 here. Any other factoring we need to do?
We can cross out the x minus 4.
Okay, so no factoring, but we can now start to cancel. So I see a factor in the top, x minus 4, but I also see in the bottom,
And it's just 1 over 2.
what's left in the top is 1, and what's left in the bottom is the 3x.
And that's right.
And that's it, we're done. Okay, you ready for these to get a little bit more fun? A lot more fun? Okay, these are gonna get a lot more fun
They
now.
are already a lot of fun.
What if we have this? V minus 5 over V squared minus 10V plus 25.
Why?
So now,
Hold on.
when you look at these, you can no longer factor them just by
Could you factor by
pulling out greatest common
by
factor.
just factoring it like you would factor a quadratic?
Exactly, yeah. So just as we would have factored this if we were, finding the zeros, we have to factor it now. So okay, let's look at the top first because it's easy. Is there any way of factoring V minus 5?
No.
No. So let's put it in parentheses to just say, we looked at that, we know that that's the only factor. How about in the bottom?
Yes.
How can we factor this?
Factors of 25 that add to negative.
I need factors of 25, positive, that add to negative 10.
So that would be negative 5 and negative 5.
Negative 5 and negative 5. So I have V minus 5 times V minus 5, or V minus 5 squared would be another way of writing that.
But would it just be 1 over b minus 5 then?
Yeah, so now I see a factor in the top, which is V minus 5, that cancels with a factor in the bottom, V minus 5.
So it equals 1 over v minus 5.
What's left up top? 1, right, over V minus 5. Should I put parentheses around this?
No.
It doesn't really matter. Now, if you were using a calculator, you would want to put parentheses around this. Like if you're using a graphing calculator or something, when we write fractions like this, there's kind of an implied parentheses around your denominator. And so when you start to get into using graphing calculators and that sort of thing, you have to get used to, okay, I have to type in my denominator inside parentheses. When we write them, we don't really need them. When we write these fractions, we don't need parentheses. All right. So that one we had to factor just the denominator. How about this one? V squared minus 7V minus 30 over V squared minus 5V minus 24. Ooh, this looks like fun. This one looks like fun because not only do we get to factor the denominator, we also get to factor the numerator. So I need factors of negative 30 that add up to negative 7. Who can think of them?
6 and 15 and 3 and 10. 10 and negative 3.
Negative 3?
It's just
Negative
negative
10 and 3.
Negative 10 and positive 3. Okay, so in my numerator I have V minus 10 and V plus 3. In my denominator, I need factors of negative 24 that add up to negative 5.
6 and 2.
12.
No,
8 and
8 and 3, but one of them has to be negative.
3.
Negative 8.
Negative 8.
Oh, that's good.
Okay, here's a tip, guys. Sometimes you'll get stuck with these. If you can factor one of them, it sometimes makes the other one easier to factor. Like, when I see this, I'm thinking, okay, in the bottom, I better have either V plus 3 or V minus 10. 10 is not a factor of 24. So I'm expecting to see the 3 come back. And sometimes that will help you. If you ever get stuck factoring one of these, look at which factors would possibly cancel out. And in this case, the V minus 3 cancels. there's a factor in the top that cancels with a factor in the bottom, leaving v minus 10 over v minus 8. And we're done. And that's pretty much as complex as we're going to get for now.
Can you still simplify it like by taking out v minus 2?
Can we take out a 2 from this? Is 2 a factor of v minus 10? No.
No, it's not 2v, it's 2v.
Okay, is v minus 2 a factor of v minus 10?
Yes.
No. So what times v minus 2 would equal v minus 10?
It's false.
Can you think of anything? Anything times v minus 2 that would equal v minus 10?
Because then you can't do it without getting a 5 here.
Right. No. So v minus 2 is not a factor. It's a good thought, right? We can only cancel things that are factors of the top with factors of the bottom. All right. I think there's one on the homework where you'll use Gary's terrific trick.